Okay, this is day 2 of our benchmark, Marking Period 3 benchmark review. So they tell me that ABCD is a parallelogram, right? And then we go consecutively. They give me where point A is. It's at 5, 4, so I go 1, 2, 3, 4, 5, and then up 4. 1, 2, 3, 4. So A should be right around here. So it's a little tricky to draw the points on here with the screencast I have, but I'll give it a shot. So that point there is A. Okay. Then we have B is at -1, -2. So he lives right down here. B. C is at 8, -2. So 1, 2, 3, 4, 5, 6, 7, 8, and then down 2. So that is point C. So they want us to find where point D would have to be so that we have a parallelogram. If A is at 5, 4, B is at -1, -2, and C is at -8, -2. So the points are sort of listed out of order here, but we can still reconcile where D ought to be. There's really two possible answers, right? If we go A, B, C, D, D would have to be off of the grid here, right? If I move over, I could either place, if we go in order, A to B to C, okay? So I need this other line here to have the same slope as B, and also be the same length as BC. So that's probably the easiest way for me to get to this point where D would be. I just figure out what the length from B to C is. So B goes from -1 to +8, so it has a length of 9. So from A, I would want to go 9 units to the right of where 5 is. So 5 plus 9 would be over here at 14, and still 4. That would be one answer. We could plot the point over there. But we could also have a parallelogram if we move our point to the left, right? We could still have A, B, C, D that way. But this is fine for our intents and purposes. So we want to go A to B to C to D. Okay, so that point would be at 14, 4. Right? So both of these have a length of 9, right? BC from B to C is a length of 9, and then from A to D would also be a length of 9, because we have 5 as our first x coordinate, plus 9 would put us at 14. Okay. So now we move from parallelogram to a rectangle. We know rectangle has a couple of unique properties. You've got all 90-degree angles in there, and then the big one for us is that the diagonals are equal to each other. Just like any parallelogram, opposite sides are equal. But if I try to picture rectangle ABCD, let me just go ahead and draw a rectangle that goes from A to B to C to D. They tell me that AB is 7x minus 6, and they tell me that CD is 5x plus 30. So what I can do here is take those opposite sides of the rectangle and set them equal to each other. So 7x minus 6 can equal 5x plus 30. And then we solve for x. So subtract 5x. And that's all they're asking us for here, is to find the value of x. So 2x over here, let's get rid of the 6 on this side, add them to this side. So we have 2x equals 36, divide by 2, and I have x equals 18. Okay. Okay, and our third question here is a lot like the first one. They're giving me points B, C, and D, and they want to know what would the coordinates of A have to be. So I'll try to plot these. B is at -7, 3, so we go 1, 2, 3, 4, 5, 6, 7, and then I go up 3, so he's right there, and that's B. and then C is at 1, 2, 3, 4, 5, and 1, 2, 3. Okay, right across from there. And then D is at 5, negative 8. All the way down here. Okay, so they want to know what would the coordinates of A have to be. Okay, so since it's a rectangle, this makes my life a whole lot easier. I know that the y-coordinate has to be the same as the y-coordinate for C, right? These two have to live and have the same slope. So if B and C both have the same, or B and C have the same y-coordinate, then down here, A and D would both have to have the same y-coordinate. So D's y-coordinate is negative 8, right? You know, his y-coordinate has to be negative 8. And then his x-coordinate has to be the same as B's x-coordinate, right? So B has an x-coordinate of negative 7. So my point A would have to be at negative 7, negative 8. Okay? So that's it for today. Just three questions on the second page of your benchmark review. So make sure you put those answers into the Unified Classroom assignment that we'll push out today.